Moving on to chapter 5, we're going to start looking at some exactly solvable systems in quantum mechanics that we use as models for molecules. In particular, the two models we'll be looking at are the harmonic oscillator and rigid rotor in chapter 5. Now, I think I'll sometimes say rigid rotor, sometimes rigid rotator. Both mean the same thing. So what are these models? So our harmonic oscillator we can represent as a mass on a spring here. So this is sort of the classical way that we look at a harmonic oscillator. And a rigid rotor is we have two masses that have a fixed distance between them, r, m1 and m2. And we're looking at it, how this spins around. And in the case of the harmonic oscillator, we're looking at how this stretches back and forth. Now, how these apply to chemistry is that the harmonic oscillator is a model for bonds. So we can kind of view a bond between two atoms here as if it's a spring. Now, this model doesn't work exactly, but it's a good first approximation that we can start with. And in the case of a rigid rotor, if we have, say, a diatomic, and this extends to polyatomic molecules as well, but say we have something like HCl. If we imagine that this bond length is fixed between them, so R here equals the bond length, we can use quantum mechanics to find what are the possible rates at which this can spin, and what are the energies associated with that angular momentum, the spinning of the molecule. Whereas here we're looking at the bond stretching. So this is a model for molecular vibrations, the harmonic oscillator, and the rigid rotor is a model for molecular rotations. So these are two of the systems that we can find exact solutions for in quantum mechanics. Just to kind of list these, the ones that we've looked at so far, particle in a box is the first one we looked at. Then the harmonic oscillator, rigid rotor, and the hydrogen atom. And anything beyond these systems we have to approximate. So even in the case of looking at molecular vibrations and rotations, this is our first, our starting point. But if we want to accurately describe these systems, they don't behave exactly. For example, the harmonic oscillator is not exactly harmonic, right? A bond is not a spring. And for the rigid rotator, bond lengths are not fixed. The bond lengths can stretch and contract as the molecule spins. And so after we talk about these exactly solvable systems, we will move on to talking about how we make approximation methods that we can use to go beyond these model systems that we have.